My name is Robert Aaron, as you have already heard, and today's topic is on avoiding number conflicts in SQL Server, also known as sequences. Now, do you need to guarantee that a number in a field will only be used once and never duplicated by another user? Have you had a situation where you needed more than one auto number in a table? Have you ever needed a lower and an upper limit of sequential numbers and you could not go beyond it? Do you sometimes have a list of numbers that you want to recycle after you get past the last one? In SQL Server, there is a feature that can handle this quite easily, and it is called a sequence. It is available starting in SQL Server 2012. Like an auto number, it can assure that a unique number will be given out each time, unless it recycles. Recently, I was asked to implement a sequence for a client where multiple users will create new records and have to fetch the next number in a specific sequence. And we could not use an auto number because the customer was limited to a certain range, not to exceed an upper threshold. When the numbers were exhausted, management would replenish the sequence anew. Now, why using an access table does not work? Now, prior to upgrading to SQL Server, users would share a table that would keep tabs on what the next number is to use, and the problem with this approach is that it's not foolproof. Two users may request the same number at the exact same time, violating the business rule. Now, to add some protection to this scheme, a locking mechanism needs to be employed, which can have matters of its own. Now, these are the steps you would normally use to obtain a unique number without sequences and using locking. You would record the last number in a table in a single field, either in a SQL Server table or a shared access backend, and you would try to lock the record with VBA in an ADODB record set using pessimistic locking. That is, you try to edit any field in the record. If you can edit it and you don't get an error, then you successfully locked the record and you have exclusive use. You can then increase the last number when you are ready and then post the record with update. If you did get an error, then you need to wait a short amount of time and try it again. And you keep trying until you can lock the record without error. Now for error handling, you could use the typical on-error, go to some error handler, or, as you'll see, you can use on-error, resume next. And right after you try to lock the record by trying to edit it, you check the error function. And if it's not 0, then you did not receive an error. That should say you did not receive it. No, if it is non-zero, then you did receive an error. Now, we will not go into the details for error handling and using ADODB record locking, since the focus tonight is on sequences. But without sequences, you will have to implement a waiting period and write your own code and test it, and not have the extra benefits you will see of using sequences. Okay, creating and using a SQL Server sequence. Before you can use a sequence, it must be created with the following sequence syntax in SQL Server. And you only need to do this once. So you would say create sequence, and then the sequence name, and then you would say as integer generally, and then you would specify a minimum value and a maximum value. This is the most minimal way you will want to create a sequence. There are other ways you can create one, and we'll see those. And you can use the following statement to retrieve the next sequence number. You just say select next value for, and then your sequence name, and then you say as whatever field name you want to call it to be returned. Now, the nice thing about the syntax to get the next sequence number is that it is very easy to use in T-SQL. You just substitute next value 4 and then the sequence name, where you would normally get a value from a field name, a parameter, or a constant. Now, the following shows how it can be used in an insert statement. You would say insert, into your table, and then the fields that you want, then the values, and then for one of the field values, you can just say next value 4, and then the name of your sequence. That's all you need to do. And then we got our other field names. So it could be used just about anywhere, but it does have some restrictions. Now, your users will need update permissions to use the sequence, to get the next number out of the sequence. But they should not be able to alter the range of the sequence. So we want to give them update permissions, but not alter permissions, but only alter permissions under certain circumstances, which you will see. So update permissions can be given using this syntax. Grant update on your sequence name to whatever user or role that you want to give it to. You can also give permissions directly through SQL Server, through SSMS, through the interface, but this is how you would do it in an actual query window. Now, to get the next value of a sequence from an Access VBA program, you can use the following statement to read the next value into an ADODB record set. So you would define into a string variable, select next value 4, then your sequence name, then as, and then the column name that you're going to get back. And then we use open my record set. And then from that, we can just extract from that record set the value that we want. Now, this is how we typically open an ADODB record set in our firm. For more information on how you can use Open My Record Set, you can click on another article in our blog, and we'll do that right now. So you can go here, and you can open record sets the same way we do at IT Impact.
Yeah, you can locate this link by just typing easy ADODB in Google, Open My Record Set, and Google, and our blog article will come up as well.
Okay, so I'm not going to go into much detail. I just want to point this out to you that this is a good way to open record sets. It's a good way to execute record sets, and you got the complete code over here. So that's all I want to point out over here. Okay? So sequences give you more flexibility than an auto number. Now, you get more flexibility, as I said, than an auto number in Access or an identity field in SQL Server. First, you can only have one auto number or identity field in a table. Although you can reseed an identity field in SQL Server, you cannot recycle values as you can with a sequence. Identity fields are still useful for primary keys, where we want some arbitrary number to identify the record and it has no meaning. Sequences, the ranges, however, can have embedded meaning. Like if it begins with a 5, it might be in this country. If it begins in a 6, it might mean something else. If the first 4 digits are this, it might be something else. So you can embed meaning in a sequence, but you can't do that with an identity or an auto number. You are also not restricted to using integers like identity. But sequence numbers can be decimal or numeric. Also, you can increment down instead of your sequence, instead of just up. And you don't have to increment just by 1. You can increment by fractions too if you're using a decimal. Also, a sequence is not tied to any specific table, and it can be used across tables, as new sequence numbers are needed for a particular table. So we're going to look at a few examples of using sequence numbers now. Here we're just creating a sequence. You don't want to say increment by 1 without putting a max and a minimum limit, because it's going to start from minus 2 billion something. So we'll look at some of these. Here we're using a sequence number in a single table. First we create the table. Then we're creating a sequence. And then we're inserting values. And just like I showed you before, one of the values is using next value 4 to get the sequence value. You could also say next value 4.
Hey, Robert, I got a quick question. I didn't know you can do that, next value for the sequence. I was using a SQL statement assigned to a variable and then using it there. But can you do other things like select statement with the values?
Yeah.
Versus next sequence, can I just type a select statement with a where clause?
You can use next value 4 just about anywhere, but there are some limitations, and I will show you those limitations.
All right.
But it is very nice. Here we're just using a variable. Okay, so we're just assigning next value 4 to this variable, and then we're just inserting the variable into the table. Now here, it shows that the sequence number can be used in multiple tables. We're creating a sequence, we're creating 3 tables. And you'll notice that the default value for the table is next value 4. Isn't that nice? So we can even use it for a default value. Okay, so now when we do our inserts, the default value is put in automatically. Okay? And we're going to see how you can do repeating sequence numbers. That's by using the cycle argument. And we will see that again. You can also use an over clause, which means you can sort over a field or a number of fields. Look at this. Select next value 4. This answers your question. Plus, you can even go further by doing over. So it's going to lay out the sequence values.
I don't understand, but what does that mean over? What does that keyword do? I guess I don't understand
It's going to sort this column. Okay? Order by, we can have one column name or many column names. It's like adding a sort, and it's going to deliver the sequence numbers in the order that you specify in this order clause. Okay?
Okay.
So you can reset the sequence number, you can restart it, and we'll look at these more. Okay, sometimes if you have a table with an identity, you might want to change it to a sequence. So this shows you how you can create a table. You can create a table with an identity constraint. You know, it's inserting a few rows. And then you would create your sequence. You would copy the values from your old column to the new column. You would start, you know, with the max value for new values. You would get rid of the old column. So you can start with an identity and later decide to change it to a sequence if you want to, like, spread that sequence over multiple tables. So sequences are very nice. So that's all I'm going to show you for those examples for now. Now, replenishing the sequence. When you want to change the range for a sequence, like when you need a new range of policy numbers, say, it should be done with a stored procedure. The following is a stored procedure that can do this. Now, the heart of this procedure is actually, right over here. All of this stuff over here is just error checking. Like we're checking to see that the sequence name is valid. We're checking the sequence cannot be null. But the heart of the procedure is actually constructing a string to run the command, and then we'll execute that command. And I'll tell you in a moment why we need to construct that string, why we just can't call it normally. Another thing that is special about this procedure is it says with execute as owner. And we'll talk about that a little more. Okay, there's some things worth noting in the stored procedure. First, we are running it with execute as owner. We do not want the everyday user to be able to alter a sequence however they would like. That's way too much rights. But we want to give users limited capability when needed to alter it only through a stored procedure. This stored procedure can be run from an Access front end whenever a new range in a sequence needs to be installed. This would normally be by an admin user who might have more SQL Server privileges than a normal user. However, this stored procedure could also be run when a new range of numbers is waiting to be loaded into the sequence, right after the current sequence is used up. In this case, the stored procedure could be called by any user who needs, say, the first
person you dialed.
Okay. Okay, we'll wait till the music goes away. Okay. Can someone take care of that music?
Looks like Ben is having problems with his interpreter. Let me see if I can
we'll
mute
wait
him.
a minute before we move on.
That's annoying. Lucy, is there any way to mute everybody but Robert?
No, not Robert.
Everybody but Robert.
Yeah. Okay, thank you. All right, so a stored procedure can be run when a new range of numbers is waiting to be loaded into the sequence, right after the current sequence is used up, and it can be called by any user, not necessarily an admin user. Okay, so we use with execute as owner to give them more rights just for this limited use. Now, users will need permissions to execute the stored procedure. And you can do that by saying grant execute on the name of your stored procedure to whatever user or role you want. And again, this could also be done through SSMS through the interface. And another thing to notice is that it is necessary to construct a SQL string and then use exec sys sp execute SQL on that string if we are using parameters. Now, the following statement will work if it's typed into an SSMS query window or used in a stored procedure without parameters or variables. This will just work. However, the following will not work. It has parameters. You cannot use parameters or variables to alter a sequence in a stored procedure. This will not work in a stored procedure. So you need to construct the string statement with the parameter values pasted in. Okay, so we make one big string statement. We call it ampersand SQL, and then we execute it. Now, the string ampersand SQL is constructed using the functions concat and quote name. It will also work if you use plus signs to make your final string, but it is better to do it like this example, which is null safe. If you use concat, it will make sure that none of the arguments are null, which will render the entire string null, and quote name will put in the proper string delimiter. So this is a better way to do it than with plus signs. Now, this stored procedure will produce or throw an error if you provide missing or bad values, and you won't be allowed to continue. We'll go back to the stored procedure. So it throws an error here. It throws an error here. So if you have an invalid name, if you have null values for parameters, it'll throw a value. It will also automatically throw a value if you run out of numbers. Okay? If all the sequence numbers are used up, it will also throw an error. So your front-end access procedure should check to see that an error has not occurred, which should only occur if the sequence runs out of numbers, if you are providing proper parameter inputs. If an error is seen, then the front end will need to cancel its operation somehow. You'll have to figure out what to do. Now we're going to look at a few examples. We'll see how to create a sequence. We'll see how to grant permissions to update a sequence, which is what we'll need to retrieve the next value. We will actually get the next value. I'll show you how to create a stored procedure to alter a sequence or to change the limits. And I'll show you how to grant permissions to execute the stored procedure. And we'll also see how to alter a sequence. And we will also use the stored procedure we created to alter a sequence. And then finally, we will look into Access, and I'll show you a form to alter a sequence and get the next value. Okay? So this is how you would create a sequence. We already saw this command. I'm actually not going to run it because we'll get an error because it's already created. This is how we would grant the update rights to our user in our front end. We can actually run this. It won't give an error. Okay? And this is how we get the next value. Let's see what the next value gives us. We got 1002. This is creating the stored procedure to alter the sequence, to change the limits. And it's what you saw before. Okay? You see our error checking in the beginning, and then this is the heart of the procedure. We're not going to actually run it. But we can grant permissions. The user is going to need permissions to run this stored procedure with these limited rights. So we can actually run that. And we can alter the sequence by just running this command. We'll do that. So now if I try to get the next value from the sequence, it gives me 1001. If I do it again, it gives me 1002. And I can also use the stored procedure. This is how I would run the stored procedure. Just use this command. This should bring it back down to 1001. So when I go over here, I get 1001. Okay? So now I'm going to show you a form in Access. Now, the only purpose of this application is to change the sequence limits and to get the next number that you may need. I'm going to actually run this. I'm going to say change sequence range. Are you sure you want to reset your sequence? Yes. It's been adjusted. Now when I get the next number, it gives me that. When I get the next number, it gives me that. Okay? So I'm going to actually show you how this works. And also I'm going to point out that these numbers are actually in a table. They're not actually gotten from the SQL Server Sequence, and we'll talk about that a little more in a moment. And it's not a big deal that you're getting it from a table. So let me show you the code. Getting the next number. We assign to a SQL string that command, which you've already seen a few times, and then we use open my record set. Now, open my record set will return no records true if it doesn't find anything. If you don't use open my record set, if you had your own code here, it could return an error. And you want to check for that error code. Now you see over here it says on error resume next. So it's just going to go right to the next statement. So you want to see if the error, and it defaults to the error number, is not 0. If you got an error, which means the error number was not 0, or if you used open my record set and this was true, you ran out of numbers. So do something here. You want to possibly undo what you were doing, preferably in a transaction. And we'll talk about transactions more in a moment. Okay? Now, the other button is simply calling execute my command, which you can also get from the same page as open my record set. And we're just constructing the same command that you've seen, execute, alter policy sequence, and then we give the name, and then we just give the start and the end. So we're doing the same thing in Access that you saw in SQL Server. Now, there's actually other ways you can call this. if you want to get more error information, you can actually use an ADODB command object, because you can get a return value. Okay? You can actually be more particular if you want in this stored procedure by assigning return values. We won't get into it right now, but using a command object will give you more fine-grained error control. We're not going to get into that right now. I just wanted to point it out to you. Okay? And I just want to show you the rights that the sequence user has. The permissions. These rights could either be given through the commands you've already seen in this window, or you can do it through this interface. Now for the sequence, we gave update rights. You saw how we did that. For the stored procedure, we gave execute rights. These stored procedures aren't related to the sequence at all. It has to do with logging in, so we won't talk about those. And we also gave membership to data reader and data writer. Now, the only reason we did that is because we have a form that is reading and writing to a table. If we did not have that form, we could actually uncheck these. If we just had the sequence, we don't need that. In fact, if we just had data writer here, we don't even need these rights. We don't need these update rights. You just need one or the other. Okay? So that's all I want to say about that at the moment. So let's move on. Okay? Now, undoing changes when running out of numbers. I'm just going to briefly tell you the best way. We're not going to go into it right now, but the best way is to use a transaction. You can do a transaction in either SQL Server, in ADODB, or DAO. Now, transactions are not part of our discussion today, but in general, it is the best way to undo things because you never get any partial changes. If an operation could not be finished, the whole thing is rolled back. However, you cannot reuse a sequence number. If something fails within your code and an operation is not completed, it does not put the last sequence number back in the sequence. The next sequence number will be new. So you may need to make some adjustments if you don't want to throw away any numbers. If an error happens, you might want to save that number for future use. Now, these are other capabilities you can set with arguments. We talked a little about cycle, which will allow the sequence to cycle again after it reaches the end, and then go to the min value again. You can evenly explicitly restart in the middle of a sequence by giving it a restart value. So let's say you have a min value of 1 and a max value of 10. You can start in the middle by giving a restart value of 5. Okay? You can also give it a cache. For example, you can ask for 50 sequence numbers at a time, and it updates the system sequence tables once every 50 numbers. This can be faster, but it also adds a risk if there is a power failure, since these numbers cannot be reused. There is also metadata, which is available. You can pull information or metadata about your sequences from a system view called sys.sequences, and it contains the following information. Okay? It contains a whole bunch of information that you would maybe want to show the user, information which you might not be interested in, but I'll show you some of the more useful information you might want. For instance, you might want to know the start value, what it's incrementing by, the minimum, the maximum value, the last used value. Is it cycling? Is it cached? How big is the cache? And when you modified it, and when you created it. So this is useful information. And let me just say one more thing about this form. This form right now is not using metadata, but it could be using metadata to get the most accurate information. But it is not a serious situation that it is not. When you are changing the sequence range, it is just putting into a table those values when you're done. It's not. Now, in the very rare circumstance, the 1 in a billion circumstance, that let's say you change this number and then someone comes along with a supercomputer right after you who is so quick. So after you change it, then someone else changes it and he updates this table, and then you have a slower computer and now you're going to update the table, but it's not the most recent information. It's not serious because, first of all, it's a 1 in a billion thing. The next thing is this will be corrected the next time around. Also, changing the sequence limit is a rare operation, but getting the sequence number is something that would be done more often. But this is just going to be corrected the next time anyways for the next user, and it's only for viewing purposes only. It doesn't affect anything for your operations. But as I said, if you really want it to be accurate, you can read that metadata and get the most accurate information. So let's go back to the metadata. This is some typical metadata that you might use. It might not be necessary to use it because you can get by without it sometimes, but you can get data about your sequences. So we're going to close out by just looking at a few web pages that has more information on sequences that you might like. We already saw this one with the examples, and we'll take a look at this. Now, we already saw all the arguments before, so this is just going to go into more detail for you on what data types you can use, and it'll give you some general remarks, but you already saw all of this, how to grant the rights to the sequence. So you've already seen this, but this is a good page, so we'll close that. It also shows you some values of metadata. Alter a sequence, the syntax is almost the same as creating a sequence, except you cannot change the data type. If you start with an integer, you have to keep an integer. If you start with a decimal, you have to keep it. Otherwise, it's pretty much the same. So we got some more examples here, and we've seen stuff like this. Okay, so I'll close that.
Good.
Next value 4. As I said, you can use next value 4 just about anywhere, but there are some limitations, and this is where you're going to see the limitations. A read-only database, aggregate function, distinct union, etc. Okay, fetch, blah, blah, blah. But otherwise, you can use it pretty much anywhere. But this will actually describe the full specification of next value 4. So this is a nice page also. We'll close that. And the last thing I was going to show you is the metadata. Okay, so this describes all of those fields that you can query on, which I've just showed you, and it goes into more detail. So that is my presentation. If there are any questions, I'd be happy to entertain them now.
Oh, what a great topic, Robert. I sure did learn a few things tonight, especially that over argument. Didn't know about that.
Thank you.
Anybody have some questions before we break? Well, we're going to have a recording of this on our website. Please, Aaron, if you'd like to join us next month, also with the group, we appreciate it. Thank you for joining us. Thank you for being here. Robert, great presentation. Thank you so much. I think you should approach Kevin Anderson to do the same topic here in Chicago. I think it'll be widely viewed as a good topic. And we will see you next month. Thank you, everybody.